Hello everyone and welcome back to my channel. And we start with some preparation work first. So what we're going to do is load our 3D model. So just drop in a window. All these files are available for you to download from the description underneath this video from the YouTube. Also hold down the Control key and drag this step file with the vise. So we have now part in the vise, okay? And for our tutorial, I'm going to use default machine, but you can use any 5-axis machine you want. First, I'm going to load my tool library into the machine group. So I'm going to Tool Manager, and I'm going to open the file location. So where we downloaded the file, and we have all the tools here. Okay, now you want to highlight all of them and move it up to your machine group. Your machine group 1 is this machine group. Okay, so all the tools are now available for you to choose. So at the moment we have our WCS set to the top of the part. Okay, let's just go here for a sec, and I'm going to switch off my vise. Okay, so at the moment we have our WCS set up to the top, but first what I want to do is machine the bottom side of this part. So let's go to View Bottom. Okay, and what I'm going to do, I'm going to set my datum on the top of this face, on the top of the same part. Okay, so I'm going to make a duplicate. So I'm going to duplicate the bottom. I'm going to call it first op. Okay, first operation. And I'm going to click right, edit. And I want to drag my Z to be on the top of the part. Okay, and I want to set that as a WCS and also tool plane and construction plane with it. So now this is my WCS, or my work coordinate system. So this is my Z0 on the part, and XY is in the center of the part. So what I'm going to do is, because I've got already selected my planes, my levels, so I'm going to save a Viewership bookmark. Okay, so if you want, you can activate it here, click on, and the Viewership will appear here. And I'm going to rename it first op. Okay, and I'm going to save this as my first op. Now if I click on it, it will go back to my saved position. Before we create our stock, I'm going to create another level in the levels manager, and I'm going to call it wireframe, and all the lines that I'll create during the stock will end up on this level. So let's go now to stock setup, and the first thing that I'm going to change is the stock plane. I want to have the same stock plane as my operation. It is just to have the same orientation when I'll be expanding the stock during the stock creation. So let's go to bounding box, and I want my bounding box to be based on the 3D model size. So I highlight the 3D model and press OK. So now I'm going to change the origin to the bottom of my bounding box and add few millimeters each side. Okay, so let's add 3 mm side here, 106, and 3 mm on the top of the face. Top face, and let's create a geometry, lines and arcs, and all those lines will go to that level that we just created. Okay, click OK, and now let's see our stock. This is our stock. So now we are ready to create our facing operation. So go to 2D toolpath, face, and do not select anything here. When you don't select any entities here or the wireframe, Mastercam will generate the facing toolpath based on the stock from your stock setup. And for this operation, I'm going to select 80mm face mill. In the cut parameters, I'm going to change the cutting method to zigzag and 0 the stock to leave on the floors. I don't want to leave any stock, and change my move between cuts to high-speed loops. I don't want to have like a straight line between the cuts. I want to have nice radius, nice high-speed loop. In the linking parameters, I'm going to change the Z value to 0 on absolute, stock, top of stock free mill, and I'm going to deactivate the retract and feed plane to 5mm incrementally. So this is our facing toolpath, and now I'm going to create a stock model. And my initial stock is going to be stock setup, and I'm going to calculate my stock based on this facing operation. Click OK, and this is our faced stock. Now we can set our first roughing operation. So navigate to toolpaths and select OptiRough from the 3D gallery. And now I don't want to leave stock on the floor, so I'm going to press this button to 0 everything, and I will have only 0.2mm on the walls, on all walls. And to add the whole 3D model, now we can right click and add remaining entity. For those using older version of Mastercam, press the select entity button and triple click on the 3D model. Toolpath control. First I'm going to select my containment pantry. Okay, and I want to go to level manager, and I want to activate my level with the wireframe from the stock. And now mode selection to wireframe and the C-plane, and select one of the lines from the top of that wireframe cube. Okay, so now tool, I'm going to use 10mm flat end mill. Stock, I want to use one other operation, and I'm going to use a stock model. And adjustment to remaining stock, I'm going to use as computed. On the cut parameter page, I'm going to change the cutting method to zigzag. And in this box here, you can change the feed rate for your conventional cuts, but I'm going to keep it as 100%. So I'm going to change my optimized step ups to go to next closest position, and by air step downs. Okay, step over distance, so distance between each pass, I'm going to keep 50% of the tool diameter. I'm going to set my step downs to 20mm. Also, I'm going to activate step ups, and in the box I'm going to use the same value that I used in step downs. If you put in both windows the same value, Mastercam will detect all the flat areas on your part, and it will generate the toolpaths on all those levels. Available in Mastercam 2021 as well. And the minimum tool radius, toolpath radius, I'm going to keep on 1mm. And micro lift distance 0.1. I'm going to change the back feed rate to 5000, and maybe keep that on 500 or 50mm. And I'm going to use motion gap size retract when avoiding the boundary or when exceeding this distance. Toolpath control, I'm going to switch off skip pockets as well. Okay, and I'm going to compensate to outside and add maybe extra 3mm. Okay, steep and shallow, I don't want to cut this 3D model all the way down, this material, so I'm going to activate maximum depth, and I'm going to limit that somewhere below the shoulder. So right click on that window, Z coordinate of the point, and I'm going to select this point to be bottom edge of this shoulder. And because I want to cut a little bit deeper, so when I rough from the other side, I'll make sure that everything is nice cut. I don't want to chip the material, so I'm going to add another 2mm, so -17. Okay, I'm going to change that maybe to 2mm, and I want just a minimum vertical retract. And to clearance the part, I'm going to do 1 mil of the part clearance. I'm going to leave those settings as I have here, default. I'm going to leave this as my default settings. So I've got tolerance of 0.025 and 85% goes to line arc tolerance. Planes, first op, first op, first op. Coolant, I'm going to use on. And rest of the settings should be okay. So this is our toolpath. Let's create another stock model. Okay. And my initial stock, I'm going to use initial stock, the stock we created before this roughing operation. And then as source operations, I'm going to use only this one we just cut, but just rough the material. Okay. Oh, if you see something like that here, and we know that we left stock, so that might be probably due to the tolerance of the stock model. So let's go back, and in the source operations, I'm going to change that to 0.03 and maybe 0.05, and let's have a look if that will have any different result. Yeah, so you can look at that. See, all nice equal stock. Okay, so now what I'm going to do is to use this operation again. So highlight this operation, right click, hold while you hold in the right mouse button, drag it into that stock model or even into that pointer, and select copy after. Okay, move this pointer down, and now we're going to change a few parameters. So go back to operation. So from the top, model geometry stays the same. We still want to leave 0.2. Toolpath control, I'm going to remove this containment boundary and use silhouette boundary. So Mastercam will create the silhouette of the part, and I'm going to keep this to compensate to the center because I don't want to touch the outside. Now tool, I'm going to select 4mm carbide slot drill. Stock, I'm still going to use one other operation, but I'm going to change it to most recent stock model. Okay. Cut parameters, I'm going to leave this as we had in the previous operation. And let's generate the toolpath. Okay, as you can see, we have some unwanted cuts, like here, a little bit in here. And if you want to ignore the small cuts, you have to use this tool with check if we can eliminate the corner radius. Okay. That is minimum of the size of this cusp. Parameters. So in our case, our tool would have to be minimum of, let's say, 0.05, because this is the size of the cusp I want to avoid. And I want to ignore small cusps that are distance of 0.05 millimeter. But if you want to use this option, you need to remember that with this, you need to use the tool that has the corner radius equal or larger than the cusp distance here. So if we want to use 0.05 cusp, your tool has to have minimum corner radius of 0.05. And at the moment I've got 4mm slot drill, and if we want to use that, Mastercam will give us an error. I'm going to show you. So as you see, OptiRest is not supported when the negative stock adjustment is larger than the tool corner radius. So what does it mean is basically your tool has to have corner radius that is bigger than that. So we've got another 4mm here with the 0.1, and let's see the result. Okay, this is good. So now I'm going to create another stock model, and my initial stock is going to be number 2. Source operations, I'm going to use only the last one. Let's have a look. Okay, so now we can see what was machined. Okay, so this was the first roughing operation, and then we used the rest mill to do that. Okay, we still have 0.2mm stock on all walls. So now I'm going to set another operation. So I'm going to highlight this operation, last one, and copy after. Okay, now I'm going to go back, and I'm going to select now my 4mm carbide slot drill, and in the model geometry I'm going to remove this value to leave stock, okay, with this button. Stock, I'm still going to use one other operation, and it's going to be the last stock model. I'm going to use adjustment to remaining stock as computed. That's correct. So now it should finish all the contours inside. Nice. Okay. So we have still some uncut areas here. So if we go and create a stock model again, last stock model to be as our initial stock, and we want to compute this new stock model from the last operation. Okay, let's maybe change the color. To blue one. So now we see what was machined here. Okay. So we still have some uncut area here, and let's have a look what we can do. So now highlight this one, copy after, parameters, so I'm going to leave that as 0. My tool, I'm going to change to 3mm slot drill. Cut parameters, I'm going to leave as it is here. My stock, of course I want to use one operation, and it's going to be this one. And I'm going to ignore small cusps, and I'm going to use a 3mm flat end mill on the machine, but I told Mastercam that I've got this corner radius, just to be able to use this option to ignore small cusps. Okay, so my tool description is still just a 3mm carbide slot drill. Yes. And now we have only one last thing left for us to do, and it is the outside contour of the shoulder, finish the shoulder. So I'm going to copy and paste this toolpath, and I'm going to change only a few things. So let's start from the top. That stays the same. Tool, I'm going to use a short 20mm carbide slot drill. Stock, I'm going to use the most recent stock model and use as computed. Cut parameters. One more, machine toolpath control, I'm going to skip pockets because I don't want my tool to plunge inside here. So I'm going to skip all pockets and compensate to outside. And it's only, I'm going to give it a room for cutter to lead in, lead out. So I'm going to add 10mm offset. I'm going to use climb to go outside, compensation left, and steep and shallow. I want to go only to that depth here. Okay, and maybe past 1 mil, so 16 mil. And I want to cut this outside in 1 depth. So I have 2 options: either switch off the step ups in cut parameter page, or while I'm here, I'm gonna add minimum depth equals -16. So minimum and maximum depths are the same. And in the result, we will have 1 pass. 1 depth. And let's try and let's test it. And this is our toolpath. So, straight line, round, straight line, round. That's good. Okay. Of course, we would cut probably all these faces to finish all these faces around with contour toolpath or something like that, just to have the compensation possibility on the machine. But I'm just wanting to show you how to quickly generate the toolpath for quite complex, quite busy 3D model. Okay, so now let's do some preparation for operation 2. Okay, for our second op. I'm going to create quickly new toolpath group, second op. Okay, and I'm going to create a stock model from this operation. Oh, another thing, if you want to simulate with this WCS used in different location than the top, if you go to machine simulation, remember to tick that. Even using 3-axis machine, tick that to be able to see the part orientated properly on the table. So now I create a new group and call it second op. And what I'm going to do is generate the stock model, the final stock model from this operation. So I'm going to go to toolpath, stock model. My initial stock is going to be the most recent stock. And source operations, I'm going to add these last 2 operations. I'm going to compute the stock model from the last 2 operations. So now I want to set my plane to top, top, top. Okay. So now we will machine this side. I'm going to add another view sheet and I'm going to name it second op. In the level group, I'm going to activate my vice and I'm going to save it in this position. Okay, save the view sheet bookmark, and this is what I need. Okay, I'm going to also create another view sheet just with the 3D model for my programming. Okay, and this stock model I'll be using just for the simulation. No levels, go here, all blank, and save viewsheet bookmark. Okay, so now let's go back to toolpaths, and we are going now to rough out this side. OptiRough, add remaining entities, and I want to add 0.5 on each wall, and I want to leave 0.5mm stock on the floor. So all over this side I'm gonna leave 0.5 after this operation. Toolpath control, nothing here, and I'm not going to use rest material. Okay, so my tool is going to be 20mm long series carbide slot drill, and I'm going to, in the toolpath control, I'm going to use a strategy from outside here. I'm not going to offset anything. So this is my settings for the toolpath control, and I'm going to change that to zigzag and 100% for the conventional cut or feed rate. That's okay. I'm going to use 40mm step down and 10mm step ups because I want to relieve a little bit of or machined off a little bit more on the angled or tapered walls. Rest of the settings here I'm going to leave, as you can see here. Steep shallow, I want my maximum depth. Right click on that window, set 70mm maximum depth. Okay, linking parameters, I'll change that to 10 and to 10 here. Okay, and the rest of the settings I'm going to leave as default settings here. That is okay. Arc filter tolerance I'm going to leave on 25 microns and 85% towards the line arc tolerance. Planes, you need to remember to have top, top, top. This is the plane for this side. Okay. Okay, this is our toolpath, and now I'm going to, because we left 0.5 mm everywhere around the part, I'm going to now finish the floor and this vertical walls around, all the faces around. Okay, so I'm going to copy this toolpath, copy after, and I'm going to change in parameters only two things. So in model geometry, I'm going to take off the values to leave stock. I don't want to leave stock, so I'm going to zero those values by this with this button here. So we're not going to leave any stock after this toolpath. I'm going to leave this the same settings, the same tool, cut parameters, and this time I'm going to go 70mm and no step ups. Steep and shallow I'm going to leave 70mm, and let's see the toolpath. Okay, so this is our toolpath. The part is roughed from this side, this face, and those faces around are finished. Now we are going to pre-finish those tapered faces around, and this will give us a good base for our finishing operation. For this I'm going to use 3D toolpath from finishing gallery, Waterline. So I'm going to leave only 0.1mm stock on the walls, or 0.15 actually, and my faces are going to be those faces around. So hold down the shift key and click on one of the faces, plus also select this top face. Toolpath control, I'm going to change that to contact point outside, and actually I'm not going to select any containment boundary. I'm going to leave as it is, and the tool I'm going to select 6mm ball nose. 6 mil diameter ball nose. I'm not going to use a stock. And the cut pattern, I'm going to change my closed contour direction to be climbed spiral. And I want to have nice true spiral going all the way down. And the pitch is going to be 1.5 millimeters. So distance between each pass is going to be 1.5 millimeter. In linking parameters, I want my lead in to be 2 mil and radius, lead in and lead out, to be the same. We don't need to set that up because we will have one continuous cut, one spiral. And I'm going to set my clearance plane to 2 millimeter, and the tool will start from 2 and will retract up after the whole cut. The tool is a bit short, so I'm going to go to holder section and I'm going to add collision checking against the holder. So holder against those faces. And I want, instead of trimming to avoid the gauge, I want the tool to tilt. And I'll give it 10-degree max tilt. Also, I'm going to select approximate start point. And I'm going to select midpoint on this top edge. Okay, this is what I'm cutting. Tool 6 mil, spiral 1.5 millimeter. Okay. This Mastercam tells you that the operation has been checked against the tool holder. Okay, and we can see now the result of the toolpath, and this operation will give us nice base for finishing operation. And you see it is nice lead in, spiral all the way down, then lead out, and retraction to Z+2. Now to finish those walls, I'm going to use a new toolpath in our multi-axis gallery called Unify. And I'm going to show you how to program accelerated finishing tool. And of course, I'm going to show you how to set the tool axis control in our toolpath, as we have new tool axis control option. And of course, I'm going to present later on how to set up in older Mastercam. And for this operation, I'm going to use one of Hoffman's group brands, which is Garant. And I'm going to use a 6 millimeter taper form carbide paromilka. Let's go to cut pattern page, and as a pattern I'm going to select a surface, and this surface is going to be our pattern 2. Okay, so I want my all cuts to be parallel to the surface that I am going to select. Press the selection button and select this face. So I want my all cuts to be parallel to that face. And my machining geometries is what I want to machine, so our drive surfaces. So hold down the shift key on your keyboard and press left mouse button on one of the tapered walls. And selection. And now, as I said, I want to have style to be parallel to the surface. So I want to change the style to parallel. Okay, now let's go to cutting method, and I'm going to select a spiral. And in this way, I'll have one continuous spiral all the way down. And I'm going to leave all those sub pages as standard or default settings. Okay, I'm not going to change anything, but I want to improve my surface quality, so I'm going to tighten up a little bit my cut tolerance. So let's go back to cut pattern page and let's finish the settings. So at the moment my cut tolerance is 25 microns because we are in metric mode. So instead of having 25 microns, I want to have 2.5 micron. So I'm going to change it to 0.0025. And my step over, which is a pitch of that spiral, is going to be 2.25 millimeter between each pass. Now when we have everything on this page set properly, we can move on. So let's take care of our tool axis control. And of course I want my output format to be on 5 axes. And my tool axis control, I'm going to have surface with tilt. And the side tilt definition, I'm going to change to follow surface ISO direction. And as you see here, this is how we had it in previous version of Mastercam. But now we can set side tilt by using an angle or a contact point. And in our example, I'm going to use contact point. And now you have contact point definition. You have 2 options to choose from, by height or by line parameter. And my contact point definition is going to be by line parameter. So now we need to tell Mastercam what line parameter you want to use, what profile section you want to use as a line parameter. If you want to use the full profile or just the barrel section of this profile. And I'm going to select the barrel section because I want my line parameter to be based only on the barrel section, on that big 250 millimeter radius. So this line parameter is just a percentage of the total length of this only barrel section. So let's say you want to use a 0 as a line parameter. So it is 0% of the length. So your contact point will be at the very beginning of the barrel section. And if you put 0.5, that means it is 50% of the length of this barrel section. And if you use line parameter to be 1, meaning 100%, your contact point between the tool and the machining surface is going to be on the very, very top of that barrel section. In my case, I want to use slightly above 50% of the length of the barrel section. So I'm going to use 65% of the length of the barrel section. And in advanced option, I'm going to add a little bit side tilt fanning distance. And I'm going to extend this to 15 millimeters. And when you use accelerated finishing tools, that improves the surface quality or your finish on the part. And in the collision control, I'm going to leave those as default. I'm going to leave only trim and relink collisions only on the machine geometry. In the linking, I'm going to add lead in and lead out. And rest of the settings I'm going to leave as default. And default lead in, lead out, I'm going to leave automatic arcs, and tool axis orientation I'm going to leave as automatic as well. But I'm going to change the arc radius to 5 and copy that to the lead out. So I'm going to have both lead in and lead out the same. That should be all for our settings. And in planes, as I usually program simultaneous 5 axes, my planes are on top. Let's see the toolpath. And yes, this is the result I was looking for. So now I'm going to set the same cut using the parallel toolpath and the settings from previous version of Mastercam. So before you do accelerated finishing, you need to get a little bit of information. Let's go now to our Mastercam and let's set our parallel operation. So as my tool, I'm going to use that 6mm taper form barrel mill. In the cut pattern, I want my cuts to be parallel to surface, and I want to select the top of this face here. My drives, hold down the shift key on your keyboard and select one of the faces with the left click of the mouse button. So all the faces around we have selected at the moment. And I want a spiral in this example. To get better finish, I'm going to add tighten up a little bit the tolerance. 2.25. I want to have my step down, or actually step over. All these settings I'm going to leave as default. Okay. And the tool axis control, I need a 5-axis output, surface with tilt, because we need a tilt to set our cutter in the right position orientation. And the side tilt definition, I'm going to follow surface ISO direction, and we do not have that in the older version of Mastercam. So now you need to set your tilt angle, and you can find this information on the supplier website, and it is specific to your cutter. And as you can see here, this is our cutter, and this is the highlighted information that you're looking for. So A/2 is your angle. So 90 degree minus that 18 and gives you the proper tilt for your tool, for this tool that we are using. Okay. And in the advanced option, we're going to change the side tilt fan and distance, and I'm going to show you what that really is. So let's set this to 1 millimeter. Go this way, set my 3D model to the side. You see my tool is in almost vertical position, and look at that, what happens when we approach. It starts tilting just before going from one surface to another. Start changing the angle just 1 millimeter before the surface here. Okay, and now let's go back, and let's now change it to 15 millimeter. When we go, the cutter already is changing its position, and we do not stop here. So we do not realign in the tool just before the going into that fillet, the side fillet. So in this way we will have nicer and more smooth transition. We won't stop the tool here to just change the angle. So our surface finish is going to be a lot better. Okay guys, thank you for watching the video and this tutorial. Thank you for great emails and nice comments. Don't forget to download your tool database and 3D model from the link in the description, and try to do this example yourself and practice. See you in the next tutorial.